Hey gang, this is Mr. Schmidt doing a recap of the October 6th AP Physics class where we talk more about projectile motion. I've already posted the answer key and the video explaining the last assignment on projectile motion. That was kind of to give you the expanse of the questions. Here we're going to break down the questions a little more specifically to get ready for the next assignment. So the start with is keeping track of vectors and scalars. So here we have a little physics beam. The Hulk finds a man who has no direction in his life. What does he give him? Vectors. Vectors have both magnitude and direction. So there's our little physics beam. What we're going to be working on today is calculating projectile motion by separating vectors into the x and y direction, calculating vector components, and applying the time variable to both the x and y vectors. Okay, so the only math we need to know is the sine and cosine law of SOHCAHTOA. Also might have to rely on the quadratic equation, although not as much today. The big thing that people get stuck with is these are our equations. Knowing which equation to use is the tough part. So we're going to start with always trying this first one, but that may not always be successful. So we may have to go on and do some guess and check or try to do some process of elimination to figure out which equation we're going to use. Okay, so like I said, this is the one we're going to focus on as we apply it to a few different examples that will become our homework. So the first question in the homework is a baseball is dropped off a cliff and it accelerates to the ground at 9.8 meters per second squared downwards. Meanwhile, a cannonball is launched from the same cliff, the horizontal speed of 20 miles or 20 meters per second. Okay, so if that is our question, we now need to break this down into a table to figure out what's happening every second. So here we have the same question and a table for how to figure this out. So what I want to do is go through the first two lines of this table, and then hopefully you'll be able to spot a pattern and you'll be able to continue on throughout the rest of this question. I'll then do one more homework question to get you prepared for the assignment, and then hopefully by tomorrow you'll have some good questions about how to complete the rest of this. All right. By the way, just a little preview. During storm time, we're going to be talking just about vectors and how do we take a bunch of weird, confusing vectors and put them all into something that we can easily solve. Okay, there is a nice video about launching a ball into a cart, and there's another video I posted on storm time or on the homepage. But right now, we're just going to focus on doing those questions. So first of all, what questions am I talking about? Okay, I'm talking about this top question right here. Right, reads exactly what I had in my slides. They have a little table. I don't really like the format of their table, but that's what they have. So I'm going to go through and do the first two lines on this on my paper. Okay. All right, so we have two different scenarios. Okay, we have a ball dropping this way, and we have a cannonball being shot over here. Okay, so we're gonna have two different situations, the baseball and the cannonball. And conveniently, some of the things are gonna stay the same. So if we're gonna have at time equals 0, we need to find our distance in the y for the cannonball, for the baseball, and our y and our x for the cannonball. Okay, so once again, we have to pick which equation should we use. I always start with my first guess being this one. That was supposed to be a y. Okay, so this is my first guess for all the things in the y. Okay, here we have time equals 0, which makes for a very boring equation, by the way. So we're calling this 0 meters, okay? And then these will be our distances coming down. So this first one is very easy, okay? Time equals 0, distance equals 0, so it is just going to be equal. All right, that's not very exciting. But what happens when time equals 1? Okay, now we need to start keeping track of things. So I'm going to do this again and try to set it up a little bit clearer. Okay, so now we know time equals 1. Okay, we need to know dy for the baseball first. Okay, well, what do we know also in the y direction? Okay, we know the baseball was dropped, right? And we know that it's on Earth and in the y direction. Okay, we're going to see this a lot, and we have to make sure we know when to apply this. And pretty much it's whenever we see a y, it's 9.8. Okay, so now we can try this equation again. And again, we're starting at 0 meters. Okay, so now we need to start putting in some numbers here. All right, so I'm going to put in my number there. I'm going to put in my number here and my number there. And of course, time equals 1 second. Okay, so 0 meters plus 0 meters per second times 1 second plus 1/2 negative 9.8 times 1 second squared. Okay, 0 plus 0 plus negative 4.9. Okay. All right, so that is where you'd put in for your first distance in the y for the baseball. Now, when we look at the cannonball was launched horizontally, which means its velocity in the x was 20, but its velocity in the y was 0. It's still on Earth, so its acceleration is still negative 9.8. It was launched from the same cliff, so its distance was 0. So this is going to be both for the baseball and cannonball. Okay. So that is going to be your y component for both the baseball and the cannonball. Okay. The only thing that's different now is then how do we figure out d sub x for the cannonball? Okay. So for the cannonball, we said velocity, or they say velocity, it is shot horizontally with a speed of 20 meters per second. The acceleration in the x, okay, this is true whether you're the guys on the trampoline or you're shooting a cannon or you're dropping a ball. If we are going to ignore air resistance, then we can assume that our acceleration in the x after the cannon left the barrel becomes 0 meters per second squared. Okay, and again, we're solving this for time equals 1. So we're going to do the exact same equation all over again. Excuse me. So, yeah, we're on the X, so I got the right. Plus, velocity of X time plus 1/2 AX. Okay, so we're solving for this. We know it started at 0. Okay, so I can put my time in. It's going to go in for T. I put 20 in right there. And I'm going to put my 0 in right here. Okay, so I'm going to have E of X, so 1, sure, equals 0, right? 0 meters plus 20 meters per second times 1 second plus 1/2 of 0 times 1. Okay, so this is going to be 0 plus 20 plus 0 . Okay, so that's going to go in for my X in the cannon. Now notice the baseball did not have any velocity, so it is not going to go forward. The cannon does, so this is for the cannon, okay, which is why the cannon has this column and the baseball does not, okay? So if we come back over here, okay, so now hopefully we've seen that we've filled out the first 2 columns, okay? And if we came over, okay, so if we come over to the one I can type on, then we're going to see that this was 0, 0, and this one we said in the Y was negative 4.9, which means this was also negative 4.9. Okay, notice our units are already on the top, so I don't have to write down the units again. Okay, and the baseball was 20. Okay, so now you can continue the pattern down the line. All right, so I then gave the students 20 minutes to do some work and come back to with some questions. I didn't see many questions about number 5. Hopefully you spotted the pattern. In the X direction, this goes 0, 50, 100, 150, 200, 250, and they ask what is going to be the next position, right? Diagram launched, positive speed, 1 second. Demonstrate your understanding of horizontal at the 5th second, after the 5th second, which sounds like 6 to me, okay? So if this is 250, next one over is going to be 300. So over here, we would put 300, okay? Now, it's much harder to do in the Y, okay? The Y, you'd have to use the equation again. You'd plug in 6 seconds into the same equation we've been using to find out the next one, okay? So hopefully you've been getting that pattern as you go along. Number 6 switches things up though. We are not talking about distance anymore. This is just asking for velocities, okay? And that through number 11 is really talking about velocity. So that's what we're, let's do one example of this before we end for the day. Okay, so we're going to put this aside and we're going to come back and look at number 6 now. Okay, number 6 starts with a ball here. It's going 20 meters per second. Okay, sounds a lot like our cannonball. Okay, and that was at time equals 0. Okay, but then at the next point, they want to know velocity of the x, and they want to know velocity of the y at time equals 1. Okay? So velocity of the x is going to be really easy. Okay? All of these should be the same because that's the same. Okay? So we can just continue that pattern down throughout the entire process. It's the y component that we have to do a little bit more work. And this is where we have to get to the choosing the correct equation. Okay? So what we want to do is look back at our notes. Okay? And think about which equation do we use. Okay? The question had a velocity and a time and an acceleration, and it wants a new velocity. So how can you use old velocity, the initial velocity, the acceleration, and the time to find the new velocity? Okay? Well, it doesn't give us distance, so we can't use number 1. Number 2 also uses distance. All right, the third one has velocities, accelerations, and times, and no distance. So that is the way to go. We're going to use this third equation here. Okay, there we go. So let's come back to our chart and look at our equations. So we said this is the equation we want to use because it gives us time, or it gives us our initial velocity. So this would be v naught. Okay, it gives us time. And if we are doing this in the y component, what's my acceleration in the y? Okay, I can use these 3 facts in this equation. Now I'm getting ahead of myself. Was this in the y? Okay, this was the x. Okay, I want to use 0 plus times 1. Okay? So that is what would go up here. Okay, so you're just going to continue that counting down the line. So this is going to be negative 9.8, this is going to be negative 19.6, this is going to be negative 29.4, okay, and then you're going to keep going down the line here. All right, so hopefully that gives you a pattern that acceleration in the x is going to stay 0. And if they ask you 5 times, it's going to be 0 all 5 times. And acceleration in the y is going to be 9.8. And it doesn't matter how many times they ask you about the acceleration in the y, it's always 9.8. Okay? And then from there, we can decide which equation are we going to use. Are we going to use this one, or are we going to use one of these? Okay? You make that decision based on what do they tell you. Do they tell you distance and time, or do they leave off one of the factors? If they leave one off, then we have to either back solve, or we have to choose an equation that makes it easier for us. Okay? I always try to find the equations first and then back solve if not possible. All right, and with that, hopefully you've covered everything you have, and you have some good questions for us to discuss tomorrow, and you have a good day.